Okay, up until now we've been looking at the Cartesian form of complex numbers. Okay, so when we've been looking at our Argand diagram, if we've got some complex number there, it's defined by how far across in the real axis it is and how far up it is, and we're defined by that. So that's your x and that's your y, and that complex number would be written as x plus y I, and so we call that Cartesian form. Okay, so Cartesian form just means rectangular, so you go across and you go up to find any point. That's the what we're talking about there. That's Cartesian. Polar form's a bit different. We still have our axes there, so I've got our real axis and imaginary axis. So if we've got a point there, it's just defined a bit differently. There's another way to be able to find a point in a plane, or to define a point. What this one does is it says, well, how far is it from the origin? Okay, so we look at that and we call that r. It's the radius, how far that is from the origin. And the other piece of information that we need to know to be able to locate this point is how far from the real axis is it. In other words, what is this angle here? And that can define any point in the whole plane. Okay, so instead of going across and up to find a point, this one we're going around by an angle to some point and then going out by some radius to find that point in the plane, and we call this polar form. Okay, and if we have some z, which is x plus yi, to be able to change this, I'll prove this in class, that sort of thing, but to change that into polar form, basically, then we have z is equal to r cis theta, and again I'll explain this in class. I'll just write what this means. Cis theta is just short for cos theta plus I sine theta, and so I'll explain that a bit later, but basically you've got cis cos plus I sine theta, and that's where that comes from, r cis theta. So we say r cis theta as a sort of shortcut, and let's just define what these are. R is the radius, and so if you look at x plus yi, how far is that radius there? Well, it's the square root of x squared plus y squared. It makes sense. Okay, and also if you look at it and if you do your tangent work, if that's theta in there, then what is that theta? Well, we know, and tan theta is equal to y over x, and basically that is all we need to know to be able to change between polar form and Cartesian form. Okay, so this is the guts of it. So we'll do an example and we'll just show you how that works. Okay, so let's just say convert. I've got one here. There's something I didn't say. I should probably say it before I move on. Also, this is important. When we come up with the angle, so let's say you've got a point there, okay, and so there's your line to the origin, and the angle is that. So that's your theta around from the real axis. So let's just say let's put in degrees, 120 degrees, but it could also go all the way around and again, and so that would be 120 plus 360, which is 480. Okay, and it could also go around another time, so that 480 plus 360. Okay, so it could go on and on and on and on, and so we need to define which one we want to talk about. And basically what is decided is that that angle, to give it a unique value, will always be less than or equal to pi radians and greater than negative pi. So we just restrict it into this this range so that everyone knows what we're talking about. It's just in between there. So negative pi from here, and it goes around to there to pi, and so it just has to be in that range. And so, and basically, when we're talking about the angle, we call it the argument. And when we restrict, so the argument is just what is the angle, and when we restrict it into this domain here, we call it argument with a capital A, and that means it's the principal argument. In other words, it's in this range. It's really, most of the time, this is what will be expected for you to find between these two. Okay, so little a argument just means any angle that you find, and capital A means it must be in this range, but I'll do more about that in this example. So let's go back to that now. So convert half, I've lost it, half minus root 3 on 2I into polar form. Okay, let's do this. Okay, so we've got our x plus yi type form, and we've got to convert that. Okay, so firstly let's find r. Now r was, what did we say, the square root of x squared plus y squared. Okay, so that is the square root of half squared plus negative root 3 on 2 squared. Okay, which is, what's a half squared? A quarter. What's all this squared? Well, root 3 squared is 3 and 2 squared is 4. And so that's all taken care of. What's a quarter plus 3/4? That's 1. What's the square root of 1? 1. Okay, so it is plus or minus 1, but the r, because it's the radius coming out from the center of the diagram, it's always positive. Okay, so 1, that's our radius. Fantastic. And the other part of the thing, we need to find the argument. Okay, so our argument will be equal to, well, let's just figure out what the argument. It was tan theta equals y over x. In other words, the imaginary part over the real part. So that's negative root 3 over 2 over half. Okay, so those 2's cancel and we get negative root 3. So tan theta is equal to negative root 3. Let's just have a think about this. Draw a little diagram. Tan theta is equal to root 3. Well, tan theta is equal to root 3 up here at pi on 3. Okay, now that's there. Where is tan theta equal to negative root 3? That will occur in this symmetrical place here, and also opposite there. So there's actually two places where tan theta will be defined as that. So this there, I'll just circle this so you can see which one I'm talking about. That is one solution, and that is another solution. Now, which one do we choose? Well, it's easy to figure out, but maybe hard to figure out because it's not obvious. From this, that's not enough information. But if you go back to this here, which quadrant is this in? Half minus root 3 on 2, it must be in this fourth quadrant here, okay? Because you've got a positive and a negative, positive real term and a negative imaginary, so it must be this solution here. So what is that angle? That will be, well, let me go. It might be negative pi over 3, so that angle there, but also could be this angle all the way around like that. So it also could be, what would that be? That'd be pi, so 4 pi on 3, 5 pi on 3, it could be 5 pi on 3. It could be any number of solutions, okay? Every time it goes around, it could be that. But so that's the argument. What would the capital A argument be? Well, the capital argument would be only between negative pi and positive pi. And so what will that be? That'll be this value here. That is the one that's in between negative pi and positive pi. And so our theta will be negative pi on 3. Great. So we've got our argument, we've got our radius, so therefore our half minus root 3 on 2 I is equal to r cis theta. R was equal to 1. Cis, what was theta? Negative pi over 3. Don't need to write the 1, such as cis negative pi on 3. And we've converted that into polar form. This here is called polar form. And there we have it. An exercise for you to do is to expand this out and see if when you expand that back into rectangular form you get back to this here. A good little exercise to do. Okay, let's do something slightly different than that, or just do exactly that. Let's convert the other way. Convert 5 cis, let's just say 2 pi on 3 into rectangular form. Okay, so rectangular form is just another word for Cartesian form. Okay, so one of those two, they both mean the same thing. Okay, so let's do that. Therefore, 5 cis, don't know why I wrote therefore. That makes sense. Now, remember what cis means. Let's just expand it out. This means 5 cos 2 pi on 3 plus I sine 2 pi on 3. Okay, that's what it means. Just always remember what cis means. You might get stuck sometimes if you forget. Shortcut for this. Okay, equals 5. Now, what's cos of 2 pi on 3? Again, I always do this. I always draw a little circle to help remind me. 2 pi on 3 is up here. Okay, so our little spot here. So symmetrically, it's symmetrical to that. There, the cos is positive. There, cos is negative. What's the cos of pi on 3? Cos of pi on 3 is equal to half. Okay, so that's half. So what will the cos of 2 pi on 3? It'll be negative half. Okay, fantastic. So I've got negative half there. Plus I. What's the sine of 2 pi on 3? So that's here. What's the sine value here? Again, look at the reflection here, the symmetrical one, and it will be the same as the sine of pi on 3, the 2 pi on 3, because that distance is the same as that distance. So what are we looking for? We want the sine of pi on 3, which will be the same, and that's root 3 on 2. So root 3 over 2. And this is almost in rectangular form. We'll just get rid of this 5 here. So that is negative 5 over 2 plus, I'll put the I last in this case, 5 root 3 over 2 pi. And that's in Cartesian form or rectangular form. And that's all we'll talk about polar form today, and we'll go on and do a bit of operations with polar form for the next video.